This is the first video in the series entitled Exploring Cimatron for Mold Design. Highlights of this series will include part analysis for mold feasibility, using quick split for cavity and core separation, creating parting lines and parting surfaces, mold splits for cavity and core block separation, creating and manipulating major mold assemblies such as slides and lifters, designing and verifying water lines, and placing ejector pins with full cutoff details. We would like to thank you for your interest in Cimatron for mold design. Cimatron is software uniquely created for mold design, covering all aspects of the process. In Cimatron, the mold designer will find his terms and definitions he works with every day, the language a mold designer speaks. In this video, we will discuss importing part geometry, starting a mold design project, and analyzing the part for feasibility. We'll begin with importing part geometry. Cimatron supports standard part translators such as STEP, SAT, and IGES, as well as many direct translators. This includes individual part files, assemblies of files, and very often PMI notes. We will begin our design project by using the Mold Setup Wizard. Here we're going to give the project its name and decide where we're going to save it at. Also, we're going to select a layout part, which is determining if it's going to be a 1 cavity, a 2 cavity, 4 cavity, whatever the layout is. And we will select the units we wish to work in. Inside the mold design environment, we see on the left side the tree, which is going to contain the assembly of components, and on the right side the guide, which will take us through all the operations. We will focus our attention now on loading the part we're going to work with. This will be a single cavity tool. We will do multiple operations in this one step. The first thing we're going to do is make a working copy of the part. Once we have selected the part, we will apply a shrinkage factor based upon the material we're going to mold it out of. And we will create another part to capture the mold shut-off surfaces, or a parting surface part. As this will be a large single cavity mold, we will position the part right on mold center. We will next consider a very handy feature called Curvature Map. This feature allows us to color code the rounds throughout the part so that we can see them graphically. We can customize the output we see by changing the range of values or setting the colors as we wish them to appear. The output we see can be flipped from male to female side. Specific features can be tagged to draw emphasis to them, and that tag will stay with the part as it rotates. This information can then be published to a PDF file so that it can be shared with other engineers or with the customer. This brings us to our next feature, which is wall thickness analysis. We're going to measure throughout the part all the different and various wall thicknesses. Using the method of sphere analysis, we will calculate the walls of the part, seeing how big a sphere would fit at any given point. Again, the output can be controlled by a range of values and colors of our own choosing. And just as we saw with Curvature Map, individual points we wish to highlight can be tagged. As each of these individual points is tagged, we can see the wall thickness changing with the geometry. And also, as we saw with Curvature Map, these results can be published to a PDF where they can be shared with other engineers or with the customer. Another nice feature to this is the dynamic clipping plane, which allows us to cut the part in section at any given point and at any given angle. We can change the display to get the results we want by simply dragging the slide bar. This takes us to our next analysis tool, which we'll use to get measurements. In addition to having nice tools for snapping quick linear measurements, such as from point to point or point to line, it will also measure angles, angles between faces, between edges, find the radius of curves, individual curves, or filleted surfaces, and it will give overall dimensions, such as an overall XYZ box, the ability to find the mass and the overall volume of the part. All this information then can be published as an Excel file or a PDF report, making it very handy for quotation. It will even give you a nice little screenshot of the part for the report. The next function we're going to consider is called direction analysis. Based upon the part's current orientation, it will look for its primary pull direction, a secondary pull direction, and anything that it finds trapped or undercut in between. You can see how this is ideal for a quick mold analysis. A quick zoom on the tabs on the underside of the part help us to see that it's identified those trapped areas that are going to require lifters. And once again, as we've seen with the other analysis tools, this information can be published to a PDF, which is invaluable in sharing with others. In conclusion, we would like to thank you for your attention to this presentation. We invite you to look for our next presentation on the subject of Cimatron and mold design, which will focus on cavity and core separation by using QuickSplit.